Now, a new world awaits us. Okay, ladies and gentlemen. Ooh, what am I doing? Okay, I'm functioning like it's midnight. Okay, great. So the next thing we're going to do is we're going to add in another state chart, and we're going to simulate interactions between the state chart. And you, ladies and gentlemen, will be telling me the key components. Okay? So tell me, how do I add a state chart to this model? Where do I go? Do I go to main? Do I go to the experiment? Whither do I go? Oh, that's interesting. Okay. So who's this a state chart? For whom is this a state chart? Is it a state chart involving diabetes? Is it Maine's diabetes? Does Maine get diabetes? Person does. People get diabetes, unfortunately. So we need to go to person, actually. And tell me how to add a state chart. I'm going to add a particularly simple state chart here. It's just kind of normal glycemic and diabetic. It's going to be very simplified. Okay, so how would I add a state chart? Good. And add a state chart entry point, right? So diabetes state chart. So remember what this means. I emphasized it before, but in a fuguish fashion, I want to emphasize it again. I want to return to this, take up the theme. So what does it mean that I have this diabetes state chart now? We're going to add in some states here. So I'm going to add in a normal glycemic state. Here we go, normal glycemic. Okay, and I'm going to keep it lowercase, normoglycemic. So that's normal blood sugar levels, and then diabetic. Yeah, diabetic. Ooh, diabetic. Okay, and then I want to add a transition between them. Boom. Okay, and this is going to be developing diabetes. Okay, and I want to show the name. Boom. Okay, but help me understand what this means. So I have a single person, a given person is going to have two state charts. What does that mean? Does that mean like if they're diabetic, they won't be overweight, and it won't be normal, and underweight won't be obese? No, they're going to be in one state for what? For okay, so they're going to be in one state for each state chart. They're going to be in some state here at the same time as they're in some state here. So with respect to weight, I'll be in a certain state. Maybe I'm overweight. In respect to diabetes, I'll be normal glycemic. Or I'll be overweight and I'll be diabetic. Now, I want to draw out for you again the fact that with an aggregate model, it gets explosively ugly when you're trying to take into account multiple lines of progression and all their possible combinations. I speak from direct experience here. And I'm someone who has I was going to say I have a strong stomach, but actually I'm quite sensitive to ugliness in models. Not so much aesthetic ugliness, but logical ugly issues where they're unnatural. The aesthetics I leave to those with better eyes than mine. So great. So here we have this nice parsing of the situation. These are factors involving diabetes, and these are factors involving weight. But if those were solitudes, you might rightfully throw me out of the room. If I said, well, this diabetes state chart will be operated totally independently of the others, you'd raise objections, and rightly so. You might call Border Patrol, and they'd ship me back on a rail or something like that. Ride me out of town. So instead, we're going to tie them together. We're going to want this developing diabetes to be a hazard, a chance per year that depends on their weight status. How are we going to do that? How could we make their chance of going from a normal glycemic state to a diabetic state on a per year basis depend on the state that they're in of this weight state chart? How could we get this state chart to kind of tell this one how likely someone is to go from here to here on a per year basis? I'm trying to send you ideas here. How can we get? I'm sorry? You have to go to transition. Okay. Transition would be normal weight and overweight. Okay. So this transition is going to need to depend on this, the value for this transition. I'll tell you, this transition is going to be a rate transition here. It's going to be a rate, a chance per unit time. Does that make sense? Okay, but what rate is it going to be? There's the rub. What rate is it going to be? Okay, it's an annual rate. Yeah, it's an annual rate. Good. It's an annual hazard, annualized hazard. Excellent, excellent, excellent. And where are we going to, from whence will that hazard come? How are we going to know what hazard? It's going to be different if we're normal and underweight, and it'll be different if we're in the overweight state and different in the obese state. And how could we know which one we're in? How could we know what the value has to be? How did we do it earlier? Did we have something which changes when they go from one state to the other? It changes something. It tells something else in the model. We used a what? A variable. That's exactly it. We're going to use a variable. Okay? Fine answer. Okay. So we're going to add, ladies and gentlemen, a variable. And this is going to be called, I'm typically going to call it diabetes hazard. Diabetes hazard. Could be named better. Developing diabetes hazard. I'll leave it at diabetes hazard, partly to compensate for my long names elsewhere. Okay. Okay. Diabetes hazard. Okay. Now, what is this rate going to be? What's the value of the rate going to be? So this rate, right now it's a rate of 1 per year. What is it going to be now? Since I created this variable, what is this rate going to be? It's going to be, yes, it's going to be the variable. It's going to be the value of that variable. Right? Okay. So this variable is going to dictate this rate. Just like a variable over here dictated the scale of the person. Remember that? How big they were? Remember that visually? Okay, so we're going to make this developing diabetes depend on diabetes hazard. Is that okay? Are we done? Is that it? You got to associate. Bang on. Bang on. So we have to, we're not done with the story yet. We don't have the logic yet to set this. Where will that logic live? Where will this logic to change this appropriately live? Where will its home be? Does it live in a platypus layer? Does it live in the burrow of an aardvark? Good. good in the entry action of overweight, the entry action of normal and underweight, the entry action of obese. That is where it lives. Tasmanian devils does not share the space with the platypus. No, instead it lives in the entry action. Okay. Okay. So here we're going to, just as we set the image scale, we're going to set the diabetes hazard. So while someone's in a normal and underweight state, their diabetes hazard might be extremely low, 0.005. Analyze chance. Okay. Very low chance of developing diabetes. Very, very low chance. Type 2 diabetes, let's confine ourselves. Okay. Meanwhile, if they're in an overweight state, they might have a significantly higher chance of developing diabetes. Is it not? True. True. So maybe they'll have a 3% chance per year of developing diabetes, or 0.03 annualized hazard. Okay. And in an obese state, maybe they'll have a 0.07 chance per year of developing diabetes. Okay. Then analyze has actually continuous value, and there's a log component if you want to understand the actual chance per year as a probability on a per year basis and a year by year basis. But yeah, so this is the hazard rate, 0.07. So for each of these, we're going to be setting the diabetes hazard, which is going to communicate with that. Does that make sense? And so this will have different rates of transition depending on what state we're in. Does that make sense? Oh, sorry. Right. Indeed. Beautiful question. Beautiful question. And that is something that we could capture. I'm tempted to show you another model which captures it, but why don't we capture it here? Indeed, indeed. So we actually have biostatistical analysis which have looked at exactly that issue using the NCDS, the National Childhood Development Survey from Britain, that 58 birth cohort, looking at diabetes outcomes based not on simply current state of weight, but on cumulative overweight. And we find that actually the cumulative numbers are better predictors than your current state. And it makes sense, right? There's wear and tear on the body that develops over time. There's glycosylation which occurs. There's allostatic load that occurs on the body system as a result of persistent exposure to adiposity, and it ends up affecting the blood glucose and insulin regulatory system. And so it's a general thing. So maybe what we'll do, I love your question here. I love your question, and although it will take us a little bit differently than the past, I had anticipated, I'd like to pursue it. So may we pursue it? Okay. Now, Dylan and his compatriot Winchell, I have in mind a task for them. This task, should they accept it, will be to put in place mechanisms to automatically accumulate this information on how long you spent in certain states. And until that time, we are left to fend for ourselves, but fend we shall. And in this case, it's not a terribly onerous thing. So, Yeah. Indeed, but aspects could be the ticket. Indeed. Indeed. Um, okay. So, ladies and gentlemen, let's suppose we want to accumulate obesity years to which this person has been subject, how long they've spent in an obese state, right? How could we do that? How could we do that? This is actually a little bit of a subtle issue, and some of the models I provided you actually do have this mechanism, but I'd like to grapple with it because it has a certain computational beauty, which I certainly appreciate, but which not all of you will perhaps gravitate towards. We'll see. We'll see the reaction of the audience, and if you lunge at me, it will not have been an encouraging start. Okay, so suppose we want to accumulate cumulative obesity years, not just how long someone has spent in here in a given bout thus far, but they may lose the weight and then they'll come back in here, and that will predispose them to diabetes. So how do we do that? Yeah, you could do it with a stock. That would be a most elegant way to do it, a stock. Unfortunately, it's also a computationally burdensome way of doing it, and it's a little bit, in my mind, it's elegant, it's beautiful, but it's a little bit of overkill for the need, because it's such a straightforward. Can I show you another way that isn't recommended by its grace? It's less gracile. In its character. Okay. So I'd like to drag in a variable. Okay. Cumulative obesity years. Prior to current obesity state. Okay. What it loses in aesthetics, it gains in utility. Believe me, I've been through this before. Okay. So this is going to total up the number of years someone has been obese up to, but not including any current obese state that they're in. Okay? Now watch this. This is going to be done. It's sweet. Okay? It's sweet. Okay. So, watch this. I'd like to drag in another variable, which is it's going to be entry most recent obesity entry time. Oh gosh, that's horrible. I don't like that name at all. Entry time of most recent obesity state. Yeah, you could say incidence time. Oh, I like that. Obesity incidence time. Thank you. Obesity incidence time. Okay. Oops. Incidence time. I really like that. That is sweet. Thank you, Rob. You saved me from a most uncomfortable linguistic quandary. Okay. Beautiful example of cross-disciplinary collaboration. Obesity incidence time. Oh, yeah. Okay. And now, ladies and gentlemen, we need one more thing. One more. one more. And this is, oh, it's beautiful. Okay, this is going to be cumulative obesity years. Boom. It's going to be a function. It's going to return for us the number of cumulative years we've been obese for this person. Okay. So what is this function going to do? Is it going to do an action or return a value? I just told you, but this should be a sanity check. It's going to return a value. It's going to compute a value for us. What value is it going to compute? Number of cumulative obesity years. Okay. Oh, I wish, you know. Okay. Good. Sorry. There's an elegance here that's deep, but is not visible at first blush, perhaps. Okay. Great. So what we're going to do is we're going to go to obese here, and when you enter the obese state, guess to what we're going to assign? Obesity incidence time. Gosh, it just makes me want to almost cry with you. So that's the current time. Did Dylan leave the room? Maybe he's weeping too. Indeed, yeah, he could. He'd appreciate this. I have confidence. Okay, obesity incidence time equals the current time. I'm really pushing the envelope with this one, with this audience. This is really advanced stuff, but I want to show it to you because it's a real issue, and it may come up after I'm flying back, and that would be most unsettling. Okay, obesity incidence time. You see that? Okay, next. So that's all we have to do right now, okay, for this point. Now, the next thing is the exit. On exit 4 here, watch this. Cumulative obesity years prior to the current obesity state, that's going to go up. By how much? It's going to rise by how much? We're going to add to it a certain value. Do you know how you can indicate add in Java? Just add to this, have this thing equal this same thing plus a value. Say plus equals some value. This basically means take this and then add to it some value that will be here, okay? And it's, with a name like that, you don't want to do it twice. Okay. We're going to add to it. What's the value we're going to add to it? By how much does this need to go? What does this thing? Is cumulative obesity prior to any current obesity state? That needs to go up by how much? If we're leaving the obesity state, how long have we been in that obesity state? Tell me that. Yes. Darn right. It's the current time minus what? Yes, the obesity incidence time. The current time. How do I tell the current time? Time this, right? Minus the obesity incidence time. Now, just to be very clear, I'm going to put these in parentheses so it's very clear. I'm just adding this value. This is the amount of time I've been in this state. The amount of time I've been obese here in this current state. I'm actually almost tempted to give it a nice name, but I'll do it like that. This is the amount of time I've been obese. I'm going to add it to this thing. Oh, boy. Wow. Oh, that's great. Okay. Oh, this thing? Oh, minus obesity incidence time. Yeah. I actually put in place one additional bit of mechanism that would be, but I don't want to layer. I don't want to pile on. Okay, great. We're almost done. We're just about done. All we have to fill in is this, cumulative obesity years for a given person. And this is where the beauty rises to a crescendo. Well, or at least it all comes together. Boom. Okay, does anyone want me to stay on this for a bit longer? To dwell on this? Okay. Jeff doesn't look overcome by the beauty. The tears are not obvious in his eyes, but okay. So cumulative obesity years. This is going to be a very simple thing. Ladies and gentlemen, suppose I'm not in an obese state right now. What's my current obesity years going to be? Is it cumulative? Maybe I've spent the last 20 years obese and I've just lost my weight for the past year. How long have I been? Is it 0 that I've been? No. What is it? It's this thing. Yeah, that's right. Okay, great. So watch this. Okay. Yeah, you're watching a spectacle, but it's not on the board. I know. Okay, fine. Okay, so I'm going to ask, are they currently obese? And if so, we'll do one thing, otherwise not. So I'll say if weight state chart dot is state active, oh gosh, look at that, obese. If they're in an obese state, we're going to do one thing, otherwise we're going to do something different. So let's start with the simple thing. You just told me, if we're not in an obese state, if we're in one of these other states, what are we going to return? Yeah, we're going to return that thing because that summarizes the entire time to this point that we've been in an obese state. We're not currently obese, so we don't have to worry that we're currently obese for a certain amount of time also. Okay. Now, for this, watch this. This is advanced stuff, and this is a very real need for quite a few models I work with, this sort of thing. But I'd like to provide solutions for people, and I apologize for the pain, but can you imagine how much more painful this would be if you were in your office alone right now? Oh, thank you. Yes, thank you. There we go. Yeah. Okay, so what do we have to return here? Now, if we are in an obese state, can we just return this cumulative obesity state prior to this? Is that the whole story? Yes, plus. Oh gosh, it's like you make me want to jump up and down. That's exactly right. It's plus. I'm restraining myself. So it's plus what? Plus. That's how long I've been in the obese state for this time. This is for all previous times, and now I need to add in how long I've been there for this time. That's exactly it. Plus the current time minus what? Obesity incidence time. Isn't that beautiful? Okay. Now, what would even be more beautiful is if we had a function that sort of summarized that, because we've used that in 2 different places. And there's a concept behind it that needs to be dignified by a name, but I'm not going to inflict that upon you. I've inflicted far too much. This is a level of pain that I try to avoid inflicting upon my students. But there's a beauty here. There's a beauty with it. This is a joy that lives forever once you have it in place. So now we have got a way. We've got this function that's going to compute our cumulative obesity years. And it doesn't have nearly it's just incomparably cheaper than a stock, fortunately. A stock will do it, and a stock would do it with greater elegance and and less mechanism, I have to say. And it might even bring tears to my eyes because of its pristine beauty, but it does come with a heavyweight sort of need. This is a beautiful thing. Okay, so let me see if I can rehearse this, and then this will be one for the ages. Okay, so ladies and gentlemen, what's going on here is we need to keep track of for how long someone has cumulatively, over their entire time, been in the obese state. They may go, and in childhood they're overweight, and then they go up to obesity in their 20s, and then maybe through intervention they lose their overweight, maybe through bariatric surgery, maybe through lifestyle changes, maybe due to enrollment in a program with social support that leads to those lifestyle changes. They've lost obesity, and so for the rest of their life they may be overweight. In all these cases, or there may be someone who ends up in an obese endpoint for most of their life. In all these cases, we want to compute for how long total, over their entire lifespan to this point, they've been obese. So what are we going to do here for this? Well, what we're doing is we're dividing it up. We computer scientists like to divide and conquer. We divide things up into pieces. And we divide this up into two cases. There's the case of people who are currently obese versus the case of people who were obese merely in the past. But more than that, for those who are currently obese, we've divided up to this case of, okay, there's some amount of time prior to this case that they were obese, some total amount of time. That mechanism is shared with the situation for those who are currently overweight and normal weight. There's some amount of time in the past that they were obese, and then there's some amount of time that they're currently overweight. So we have this variable that's kind of keeping track of their past exposure to obesity, and then if they're currently obese, we have to deal with kind of some added tag on to that, some added amount that they've been obese for this particular episode. So this variable here with this god-awful long name, that's a variable summarizing sort of for how many years they were exposed to obesity prior to this episode, any current episode of obesity. And if you're in a normal or overweight state, that's all you have to return. It's that total amount. Every time you're obese, this gets computed. When you leave the obese state, it gets added on to here. And this keeps a running total for that when you leave that state. But if you're currently obese, your total exposure to obesity is going to be whatever in here from past episodes plus the length of your current episode. And the length of your current episode is beautifully given by the current time minus the entry time into here. Does that make sense? Okay. So that, ladies and gentlemen, allows us to compute that. Okay. So here we have a computation of cumulative obesity years. And to bring this full circle, to deal with Joe's question, suppose we wanted this rate to no longer depend on just their current diabetes hazard as specified here, but by their, according to this, but suppose we wanted to depend not just on their current state, but on their cumulative history of exposure to obesity, right? How do we do that? Well, there's kind of two, the sort of way that I would recommend doing this would be you have a certain component of your current weight status, and then you have a certain component that's related to this cumulative obesity year. So there's kind of a beta for each. Some beta indicating the influence associated with current weight, and then another associated with cumulative weight over all those years. And I would make this guy here, the rate here, a combination of those two influences. So you could think of it as kind of beta for the current weight times your current weight status plus beta for the other one times your cumulative. And you could put that into the formula here. Does that make sense? So that's the way it could be done. Should we do it? Can. Yeah. Oh, do we not? No, we don't, because that's a great question. Great question. So why is it that this thing for the exit action and this action here are only entered in the obese state? It's because this variable specifically relates to years what? Years obese. So we're not keeping track of how many years people are overweight, for example, or how many years they're normal and underweight. It's only this obese. And so what's going on here? It's a very good question. What's going on here is this entry action remembers the time when they started this episode. This exit action basically takes the difference in the length of the current episode as dictated by the difference in the current time and that time when they started this episode. So it takes that length of the current episode and it accumulates it into this so that we remember their kind of current exposure. And we only have to do that for obese because we're only keeping track of the number of obesity years rather than years of overweight or normal and underweight. So we don't need to do a comparable thing up here. Now, of course, if we wanted to record how many years overweight or normal and underweight, we would need a similar mechanism, but we're not doing that. Does that make sense? Yeah, sure. And as I had said, Rob, did you have a question? Okay. So as I said, I know this is really stretching it. This is perhaps the most conceptually sophisticated thing I've inflicted on any boot camp audience in recent years. I try to spare people this, but this is an interesting episode of a very practical problem that comes up. The solution is not, okay, you may not share my weakness for crying for it, but it's at least not hideously ugly. Do you agree? Do you agree? I didn't say ugly. I said hideously ugly. Okay. But it's not that bad once you know what to do. The question is where to do it. It's a delicacy issue rather than massive amount of work. It's just it demands finesse rather than brute force. So here we have a real life case of something that's about as subtle as they get for common. This is not common task, but it's a semi-uncommon task. But it is a practical enough need. I wanted to record it for the web and to show how this is done. And I will happily nuggetize this. Okay, so here.